Okay, the law of cosines is just another formula that we can use to solve triangles. We use it in the side angle side case and side side case. So first we're looking at the side angle side because it is the most straightforward. We have our A, B, C. In this case we're given side A, side B, angle C. So on the previous page you had 3 different versions of the formula. It's all the same formula. It's just a matter of kind of which angle you have. So in this case, we have angle C. So that means I'm going to use the version with cosine of C in it. And a good way to remember how it works out, if we have angle C, that means it's going to be equal to side C. And so now our formula is C squared equals A squared plus B squared minus 2AB cosine C. So in this case, first thing we're solving for is side C. So now we plug everything in. We have C squared equals 2 squared plus 3 squared minus 2 times 2 times 3 cosine of 60. And we can really plug that whole thing in our calculator. Just as a heads up though, with some combining like term stuff, 2 squared is 4, 3 squared is 9, so 4 plus 9 is 13, minus 2 times 2 is 4, times 3 is 12. So if we simplify this down a little bit, we get 13 minus 12 cosine 60. One really important thing to notice, this 12 is attached to the cosine 60. The 13 is not, so you cannot subtract that 13 and 12 there. Just be careful with that. At this point, just plug it in your calculator as it says. So 13 minus 12 cosine 60. We get, so C squared equals 7. Solve by taking a quick square root. And we get that C equals 2.65. So now we're solving the triangle, so we need to finish finding everything else. At this next step, we have to solve for one of these angles. Now we can either do law of cosines again, or we can switch over and use law of sines. The main thing you want to remember though here, and I'll explain more tomorrow, is when we use law of sines, you want to use the smaller number first. So we want to solve for a smaller angle first, which in this case is going to be angle A. So we have 2.65 over sine of 60, so that was C over sine C, equals 2 over sine of A. Cross multiply, divide, take an inverse sine, and we get A equals 40.81 degrees. And now for your last angle, you can just subtract from 180, do 180 minus 60 minus 40.81, and we get 79.19 for angle B. So your key things to remember when you're setting up the equation, the angle you're using should be the same letter as the side you're setting it equal to. And then after you get this first side, when you move on to your angles, if you're using law of sines, make sure you go for the smaller angle first. So use the smaller measurement. So now looking at a side case. And this one, again, it's just plugging into the formula. You just have to be careful with order of operations on this one. So if we do A is equal to 4, B is 3, C is 6. So first, we can pick any angle to solve for. It doesn't matter which one. I always like to go with the biggest angle, and I'll explain more about kind of why I'm choosing different angles tomorrow. It all falls down to that ambiguous case from law of sines. But for now, I'm just going to use the biggest angle to start. So we're solving, where's my marker? We're solving for C, which means we're going to set the problem equal to C. Back the same formula as last time. And then fill in the rest of the formula with A's and B's. Now just plug everything in. So we have 6 squared equals A is 4 squared plus 3 squared. So now, the only thing that makes this one any more difficult than the last one is we actually have to do a bit of solving. It's not just plug the whole thing in. So we'll do one step at a time. 4 squared, 16 plus 9 minus 2 times 4 is 8 times 3 is 24. Cosine of C. So equals 36. We can still simplify on the right side. 16 plus 9 is 25. So now the most common mistake when solving for the angle here is you cannot combine these numbers. Just like I said on the last slide, that 24 is attached to the cosine of C, the 25 is not. So we can't combine those. Essentially, if we take this back to like a basic linear problem, it's kind of like our problem says 36 equals 25 minus 24x. That's just a better comparison for you to see. So now at this point, to solve, you think back to basic math 1, subtract that 25 from both sides. Same deal here. Subtract the 25 from both sides, and we get 11 equals negative. Don't forget that negative is there. 24 cosine of C. Now divide both sides by that negative 24. And we get cosine of C is equal to negative 11 over 24. So now to solve for C, take inverse cosine of negative 11 over 24. And we get C equals 117.28 degrees. So the reason I like to use that biggest angle first is because remember when we talked about law of sines, we can't take inverse sine and get an obtuse angle. Well, cosine was quadrants 1 and 2 way back from first semester. So when you take inverse cosine, you can get that obtuse angle. Now we've dealt with that problem. The other two angles will be acute. We don't have any questions to it. So now we need to solve for A and B. Just use law of sines at this point. It's easier. So we have C, what was it? C over cosine of C. Sine of C. Whoops. Sine of C equals, we'll do B first. 3 over sine of B. Cross multiply, take your inverse sine, and you get 26.38 for angle B. So now find, lastly, angle A by just subtracting, because we have 2 of the 3 angles in the triangle, subtracting from 180. So 180 minus 117.28 minus 26.38. And we get angle A is 36.34. So law of cosines is used if you have side, 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 angle, side. Other cases use law of sines. You can mix them together like you saw in both of these problems. It's all just a matter of what do you have, what are you solving for. Use whichever formula makes it the easiest.